Now today's class from starting from the end of the previous class. That means here how to convert a regular expression to null NFA. That means conversion of null NFA from a regular expression. So you are already known about that in the finite here in automata in the previous year, previous semester. You already read those basic things how to convert the null NFA to how to get the null NFA by using the regular expression from a regular expression. First, R equals to A. You already see from the node, from the start node, you are going for the A input to the final state, start state to final state for A input. R equals to A. When R equals to null, that means for null input, that is a start symbol, that is the what end of the end states also. And when you are finding out the R equals to empty, that means there is no, you are not reaching to any final state. Empty means what? You cannot reach to the final state. So here is no final state is there. Here is the initial state, but from here, from that initial or kind state, you cannot reach to the final state. There is no final state here. So for that, you can see here, these are the basic things, basic conversion from regular expression to null NFA. Now going for the next slide. I'm going for the slide so directly. Going for the next slide. Here, R equals to S plus T. S means another regular expression and T is another regular expression. To define regular expression S and T, for S you already draw the null NFA. For T you already draw the null NFA. That means for S regular expression you already draw this. For T regular expression you already draw that null NFA. Now we have to find out R equals to S plus T. That means S concatenation union. S union concatenation. So S plus T or S or T, you have to find out here by using that procedure. You already know in the class when that automata is already I'm discussing there. By using null, you already find out how to get S plus T or S or T. So starting from the start symbol, start node here for epsilon, you are going to the first node of the S. And for epsilon, you are going to the first node of the T. Here, from the last node for epsilon, you are reaching to the final state. From the last node for epsilon, you are reaching to the final state. So that is the basic symbol how to get the null NFA for R equals to S plus T. Any confusion? Okay. Now going for R equals to ST, S dot T. Here is the concatenation. Now S dot T means that means the last node is connected with the first node of T by using the null symbol, by using null transition. And here is the first node of S is the starting node and the last node of T is the final state, starting state and final state, start state. Okay. So that is the HT. And now coming for R equals to S star. S star means here is clean closure. Clean closure means some iteration, some number of times of iteration you can get. How many time you want that you will get that time of iteration. That means finite number of iteration you can get here. Now how we can get it? If you know that is the S and S, this one is for S regular expression. That is the null NFA for S regular expression. Now for that regular expression, what you are finding out to R equals to S star, what you are going from the last node of the S, that is coming back to the first node of the S by for null transition. And the first node of the S from the starting node here for epsilon value, you are going reaching to the first node of the S. From the null value, directly you are reaching to the final state here. And from the last node of S for null transition, you are reaching to where? Final state. So that is the basic structure to find out the null NFA for the regular expression S star. Okay, any confusion here? You already know those. Again, I am telling, already know those actually. So any confusion for those? Be careful about that. Clear those because you have to draw the DFA or NFA directly from a regular expression by using this method. By using this procedure, you have to find out the null NFA first. Forget about all those, what you are doing. Now we have to use some mathematical way, some algorithm. Mathematical way means algorithm. Here, what you are doing, the previous automata things, simple way from DFA, NFA to DFA conversion, that is very much easy regular expression. For regular expression, for easy regular expression, you are doing those. Now, if a regular expression is very much hard or very much big at that time, you cannot use those. You have to forget those. You have to use this procedure. So be careful. Try to solve that now. Try to solve that now. Try to understand very carefully. Most of the time, according to the previous year, I already see one question already comes from conversion of regular expression to DFA. Regular expression to DFA. Another thing I already forget to give here the note. Regular direct conversion from regular expression to DFA. I already forget about that. By using DFD, I have to insert that here also. I already forget about that. So I will discuss it later. Now coming for that, let's see here how to convert. Let's take an example. One example, you are taking AB plus A whole star. Now for A, we can find out if that is the initial state. For A input, you are reaching to the final state. For B, from the initial state for B input, you are reaching to the final state. Now for AB, what will be the regular expression? AB means here A, here for epsilon value, you are reaching to the starting node for B, and for B input, you are going to the last state. So that is the addition of A and B, concatenation of A and B, A dot B. Concatenation of AB. AB means A dot B means concatenation of A regular expression, B regular expression. By using null, you can see concatenation of two. By using null, you can doing it. AB. A means S, B means here T. So when S and T is doing by using null, you are entering them. So here you are also entering by using null. Same operation you are doing, what you are doing there. So no confusion. Going for the next slide. Here A plus B plus A. AB plus A. Plus A means what? You can reach into the final state for AB input. Also, you are reaching to the final state for A input also. So how we can doing it? Plus A means, so here AB plus A, that means here is S is AB and T is A. So if you are finding out what is the S, S means AB plus A. Here is S means AB and T means A only. So here is the AB. AB you already find out for that. This is the AB. Now to find out plus A, what you are doing, one extra epsilon is connecting with them. Here you can see here is starting node. By for epsilon value you are reaching to the start node of X, and you are reaching to the for epsilon value you are reaching to the start node of T. So here you also doing it same way. For from the start node for epsilon value you are reaching to the A first node of AB, and you are reaching to the first node of A for epsilon value, and for epsilon value you are reaching to the last node. All right. So that is for AB plus A. Now to find out the AB plus A whole star, how we can get AB plus A whole star? Moving it. Okay. Now see it. AB plus A whole star. That means, so again we are coming back. S star, S, AB plus A, that means S. Now we have to find out S star. S star means S star means what? Here we are entering from a starting node. For null value you are reaching to the start node of S. For null value from the last node you are reaching to the final state. Here is for null value, and from the last node of S you are reaching to the first node of S by using null value. Is it same operation you are doing here also? S star, that is S, totally S. From the last node for epsilon value you are reaching to the first node of S. Now for epsilon value you are reaching to the first node of S from the starting node, and from the last node of S for epsilon value you are reaching to the last node, and here from the starting node for epsilon value you are reaching to the last node. Okay, So that is the procedure to find out the regular null NFA from the regular expression. Okay. Now you can see here is the already find out that now if I am asking to convert it, let's tell a plus b whole star. First find out a plus b whole star yourself. Draw it yourself. I'm not at the time you have to upload. Only draw it. A plus b whole star. A plus b whole star. Draw it yourself. After that, I'm giving you another example. So for that time being, I'm waiting for. I'm giving you how many times? No, all right. I'm coming back later. Giving example is coming for later. I'm giving forward now. After that, the completion of that, totally I'm giving you example. Now, what are the algebra for regular expression? Commutative law. Again, coming back to the expression of algebraic expression for commutative law. L plus m equals to m plus l. That means two regular expression union. Two regular expression union is equal to the opposite of two regular expression of union. Same. L plus m equals to m plus l. That is called commutative law. Next, বৃষ্টি এসছে একটু দাঁড়াও. Excuse me, wait for a second. Okay, come back. So that is known as commutative law. L plus m equals to m plus l. As you know, if let's take an example with the previous example, ab plus a. Let's l equals to ab and m equals to a. So you can also write m plus l, a plus ab. Same thing, ab plus a equals to, we can write a plus ab. Same thing. When you are drawing it in the null NFA, you can see it here. The previous example. We can see it here. One, you are drawing AB plus A, that is the AB plus A. If you are oppositing that picture, A is in the upper case and AB is in the lower case, same operation you are doing. AB plus A equals to, we can tell it A plus AB, same. A plus AB, same. There will be no problem for that. Next, algebra for regular expression. Next, associative law for union. L plus m plus n, that can be written as L plus m plus n. Associative law. L plus m plus n. L plus m, that is operating first. After that, you are finding out n. Now, that is union of L plus m, L and m, that is union with n. Now, you can write it as L union, the union of m plus n, m and n. Both are same. You can write it, you can see it also there. Associative law for concatenation also. You can write L plus Lm whole into n, that can be written as L into mn. All same. Now, one thing you have to remember, no commutative law for concatenation. For concatenation, there is no commutative law. Lm not equals to ml. We cannot tell it. Lm not equals to ml. L is 0, m is 1. So 0, 1 cannot be 1, 0. You know already. L equals to 0. Let's L, the regular expression is 0. M is the regular expression 1. So 0, 1 is not equal to 1, 0. So you can write, see here, there is no commutative law for concatenation. Do you understand that? Any confusion? Any confusion for those laws? All right. Going for the next slide. Now, algebra for regular expression. Identity for union is L plus MT equals to MT plus L equals to L. That is the identity for union. Identity for concatenation L. Here is the null. We can tell that L null equals to null L equals to L. Concatenation. This is the identity for concatenation. For union, L plus phi. That is for empty set you are using. Here is null we are using. Another is annihilation. Annihilator for concatenation is phi L, L phi equals to phi. You already see that will be already empty when you are concatenate a regular expression with the empty set. Left distributive law. L into L union M concatenation N, then that can be drawn as L union M concatenation L union N. You already see here distributive law, and right distributive same M plus M union M concatenation L N whole union L means this is the identification law. L plus L equals to L. L plus L equals to L, identification law, identification. Okay. Next, law involving closure. You already know those. Actually, when I'm discussing about the regular expression identity rule in the automata, you already see there all these rules. You already read there those. Now L star whole star equals to L star. Next phi star equals to null M null, and null star equals to also null. L plus equals to what? L union L star. L star union L. That means there must be means L. There will be no null. As you know, L plus means what? L star minus null. L star minus null. So that can be written as L star or L star L. Same. More of a definition than a law. L star equals to L plus already null plus null. And what is that? E null plus L. How we can get? We cannot know what will be the value. Null plus L. We can directly go to the for null. We can directly for L input you are going to the final state. Okay. Now, very important. From implement NFA with epsilon move to DFA conversion. What is the procedure? How to convert a null NFA to a DFA by using algorithm. Here you can see E-closure, one function we are using, epsilon closure for a given state A means. What do you mean by that? Epsilon closure. Here we are finding out. Epsilon closure for a given state A means a set of states which can be reached from the state A with only null move, including the state A itself. That means if you want to find out E-closure of A, what will be the value? There must be a must be included along with that from A for epsilon input where we can reach directly. For epsilon input means no input you are giving, you are directly going to the another state. This state will be included there. That is known as E-closure. E-closure for a given state A means a set of state which can be reached from the state A with only null move, including the state A itself. So by using that, we have to find out the DFA from a NFA. Okay, let's see here. Wait for some times. I'm coming back 5 minutes. Okay, coming back. Now, steps for converting NFA with null to DFA. What are the steps? Step 1. First, we will take the equalizer of the starting state of NFA as a starting state of DFA. Starting state of NFA should be starting state of a DFA. That should be equalizer of starting state of NFA as a starting state of DFA. Second one, step 2. Find the states for each input symbol that can be traversed from the present. That means the union of transition value and their closure for each state of NFA present in the current state of DFA. That is the algorithm actually. Find the states. We have to find out the state for each input, every input symbol that can be traversed from the present. From the present state for every input where we can reach. We have to find out those. The union of transition value and their closure for each state of NFA present in the current state of DFA. Present in the current state of DFA will be taken as consideration. Next state, if we found a new state, take it as current state and repeat step 2. If the union of transition value and their closure for each state of NFA present in the current state of DFA, this is a new state we are getting. That means take it as current state. Otherwise, repeat step 2 and repeat step 2. Repeat step 2 and step 3 until there is no new state. The process step 2 and step 3 will be repeated until you are not getting any new state. No new state. There is no new state present in the transition table of DFA. Step 5. Mark the states of DFA as a final state which contains the final state of NFA. As you know, mark the state of the DFA as a final state which contains the final state of NFA. Contains the final state of NFA. We are coming for that. Let's see the example. Here we can see the example now. Let's take an example. Convert the NFA with null into its equivalent DFA. We are taking from Q0, Q1, Q2, Q3 and Q4. From Q1, 0 input, you are going to Q3. For Q2, for 1 input, you are going to Q3. And from Q3, for 1 input, you are reaching to the final state Q4. Now, what you are doing? Step 1, let us contain the equalizer of each state. Equalizer of each state. Let's equalizer of Q0. From Q0, for epsilon value where we can reach. Where we can reach. As you know, for a equalizer, the Q of any node, that node should be included. That means equalizer of Q0 means Q0 must be included. After that, from Q0 for epsilon value where we can reach. From Q0 for epsilon value, we can reach to Q1 and Q2. So they are included. So equalizer of Q0 means Q0, Q1 and Q2. Okay. Now equalizer of Q1. So Q1 is included now. From Q1, there is for epsilon value, there is we cannot reach anywhere. So equalizer of Q1 equals to Q1. And again, same procedure, equalizer of Q2, Q3, Q4, all are same as Q2, Q3, Q4 correspondingly. There is no change. You can see here. From Q2 for epsilon value, we cannot go anywhere. From Q3 for epsilon value, we cannot go anywhere. Q4 for epsilon value, we cannot go anywhere. So equalizer of all these values we are finding out first. Next, what will be the procedure? Now let equalizer of Q0. So Q0, Q1, Q2. That is a starting node of DFA at the name A. As you know, this is a new node. So we are stating at this is A. From A, delta dash A for 0 input, for 1 input we are finding out. Equalizer delta Q0, Q1, Q2 for 0 input. Again, we are coming back for move function. But here we are not directly using move function. Directly not using. That is happening here. If you are moving those equalizer, this is a move function. Delta move, delta Q0, Q1, Q2, that for 0 input, for 1 input. This is for 1 input. They are the move function actually, move function. For 0 input where you can moving, for 1 input where we can move. Actually. Now, let's see here. From Q0, equalizer of A means what? Q0, Q1, Q2. So delta Q0, Q1, Q2 for 0 input. So that means delta Q0 for 0 input. union delta Q1 for 0 input, union delta Q2 for 0 input, where we can reach. Let's see it. We can reach from Q0 for 0 input. We cannot reach anywhere. From Q1, we can reach to where? Q3. From Q2 for 0 input, nowhere. So only Q3 will be there. Enclosure of Q3. So Q3, call it a new state, state B. Q3 is the state B. Next, for A input, from A for one input, again we can see here from one input from Q0, Q1 and Q2 only we can go reach to Q3. So for one input we are going to the enclosure of Q3 means Q3. So that should be B. Same. That is already previous one. Now that is the partial DFA. From A for 0 input for 1 input. You are reaching to B. Next, from B now for 0 and 1. From B for 0 input, from B for 0 input, from B means Q3. From B means Q3. B means Q3. For 0 input, we cannot reach anywhere. For 1 input, where we can reach? Q4. So that is written here. For 0 input, we cannot reach anywhere. So that is 5. For 1 input, we can reach to Q4. That is the state C. For state C, for 0 input, 1 input. From 0, we are reaching to 5. And for 1 input also, we are reaching to 5. Because after reaching to Q4, there is no input is given. So we are reaching to the 5. 5 means empty state. Now, what will be the DFA? So that will be the DFA A to B for 0 and 1 input. For 1 input, you are reaching to C. Now, from C, there is no new state comes. So that is the end of that procedure. Now you are drawing that DFA where you can see what will be the final state. Which is the final state for NFA? Q4. Where is the Q4 is there? Q4 means C. Q4 means C. Let's state C. So C will be the final state here. Okay. So you can see to convert from regular expression to NFA and NFA to DFA directly. Okay. Convert the given NFA into its equivalent DFA. Let's take an example here. Forget about that. Okay, you can see the second example. Time is surprise. You can see the second example now. Q0, Q1, Q3. Self loop is there for 0 input. Self loop is there for 1 input. Here is a self loop for 2 input. You can see it. An epsilon. For epsilon, we will add the epsilon. From Q0 for epsilon value, you are reaching to Q1. From Q1, epsilon value, you are reaching to Q2. Again, what we are doing, we are finding out the enclosure of every nodes Q0, Q1 and Q2. From Q0 for enclosure, where you can reach? From Q0 for enclosure value, we are reaching to Q0 to Q1, and from Q1 you are reaching to Q2. So for enclosure of Q0, that should be Q0, Q1, Q2. Next, for enclosure of Q1, Q1 must be there. After that, from Q1 you are reaching to Q2. So Q1, Q2. Enclosure of Q1 equals to Q1, Q2. And enclosure of Q2 must be there. After that, from Q2 for epsilon, we cannot reach anywhere. So that is the Q2. Now tell me, any confusion here to find out of enclosure of every node? Any confusion? Tell me. Any confusion? Hello?
No, sir.
No, sir.
So you already find out the enclosure of every node? How to get it? Now
yes,
going for বলো কারো অসুবিধা আছে? Any confusion?
No,
Any
sir.
confusion?
No, sir.
Okay, let's start. Now for let a enclosure of Q0 is, that is the Q0, Q1, Q2. Let's state A. From the state A for 0 input, for 1 input, and for 2 input. 2 defined input are there. 3 defined inputs are there. 0, 1 and 2. For 0 input, where we are reaching Q0, Q1, Q2. That means A. This is not a new state. Now for 1 input, you are reaching to Q1 and Q2. For 1 input, from Q0, Q1 and Q2 for one input where you are reaching. Where you are reaching. For one input from Q1, you are reaching to Q1 and also you can reach to Q2. So Q1 and Q2, equalizer of Q1 means equalizer of Q1 means that should be Q1 Q2. That is state B. That is state B. And equalizer of Q0, Q1, Q2 for two input. Again we are finding out equalizer of Q2. Equalizer of Q2 means what? Equalizer of Q2 means Q2 only. So that is C, state C. Now again for B we are finding out equalizer of A0, A1, A2, ABC. The partial DFA will be like that. For 0 input A, for 1 input you are reaching to B, for 2 input you are reaching to C. Now from B, equalizer of B, B0, B1, B2, equalizer of delta 0. So that will go for equalizer of null. Actually, for 0 input, we cannot reach anywhere. For 0 input, you can see for 0 input where you can reach from from B. B means what? B means what? Q1, Q2, Q1, Q2 from Q1, Q2 for 0 input. Any input are there? No. So for that is given for 0 input that is 5. For 1 input where you can reach Q1, Q2, B itself. For 2 input that is reaching to Q2 only. That is C itself. That means we can tell for B0, 1, 2 that should be 5, B and C. So what will be the partial? From B for 1 input you are reaching to B directly self loop. For B for D input you are reaching to C. Okay. Next. Now for C input 0, 1 and 2. For 0 input that is going to the 5. For 1 input that is going to 5. And for 2 input that is going to Q2. Q2 means C itself. So we can write it hence the DFA like that. Why? All the final state? Why they are all the final state? Any idea? Why they are all final state? Yes. All A means under A there is Q2. Under B there is also Q2. Under C there is also Q2. So all these contains the Q2. Here you are saying A equals to Q0, Q1, Q2. Q2 lies hence A is the final state. B is Q2. Q2 lies hence B is also final state, and C itself is a Q2. That means that C is also a final state. All right. So that is the procedure to convert to get DFA from a null NFA. Okay. So up to that, I'm giving some example. Convert it yourself. A plus B whole star into, that means I'm writing here. Example for exercise I'm writing. Here is the example. A plus B whole star dot B A star. There is not B A star. I'm telling here B dot A star. That means B A star means B single, not B A whole star. B dot A star dot B dot B star dot B thak. Find out the null NFA and corresponding DFA. All right. Try to solve it yourself and submit it.